Sir Isaac Newton gave us the theory of gravity, force and motion. You know that the great discovery of gravity by the falling apple. What is that?
One day, Isaac Newton was reading under an apple tree. Then, apple fell on his head, and he thought, "Why does the apple only fall on him? Why not the stars? Why not the sun falls on him?" That's when he discovered the gravity.
You said very nicely, but it is not like that. He thought the apple why fall in his head? It may go upwards, another direction. Why fall in directly in his head? So he thought that something is pulling the apple downwards. What is the thing? He thought that something is like magnet pulling the apple from upwards to the center of the earth. So it is falling in downwards.
Pause.
The earth is pulling everything towards its surface. Okay. So he gave the theory of gravity. You know, each and every object attracts themselves. You know, and the amount of force, attraction force, is proportional to its mass. The bigger mass has the more force. Okay. Now we are going to learn about the laws of motion given by the Newton. He gave 3 number of laws. Okay. First is, if a moving object is moving, if no one force is acting on it, it will keep moving on a straight line. Okay. So first law says that unless it is disturbed by a force, an object will either stay still or travel at a constant speed in a straight line. That means if we are not push this book from this table, the book will stay here. Okay. And another thing is, if a moving object we are not push any force, the moving object will keep moving on and on. Okay. The second law is, the force acting on a body is equal to its rate of change of momentum, which is the product of its mass and its acceleration. Momentum is the rate of change of velocity, and multiplication of rate of change of velocity and its mass. Means we have to give more force to move a bigger object. That means if we want to push this book, the energy required is more if we want to push the almari. Okay. If we want to move the almari, we have to give more force. If we want to move this book, we have to less force. Right. Means another thing, if you want to stop a cycle, you have to give less force than if you want to stop a car. You cannot stop a car, but you can stop a bicycle by your hand. Okay.
Feet also.
My feet also. So what is the reason behind it?
Because cycle is lighter than the car.
Yes. If you want to stop a train, you have to give more force than the car also. Okay. And another thing is that if a cycle is slow, you have to give less force. Then if the mass also if the mass is same, means cycle is mass is same. If it is in speedy condition, you have to give more force to stop it. If it is slow, you have to give less force. That is the second law. You understood?
Yes.
Give me example.
Um, when you want to stop a bicycle, you have to give force on it.
But it depends on what is the speed of the cycle. If it is more speed, you have to give more force. If it is less speed, you have to give less force. Another thing is that if the speed is same for two objects, the force required is heavier is the object mass, the force required is more. Okay, if the car and the cycle is in same speed, you want to stop it, you have to give more force in the car. If a car and a train is in same speed, you want to stop them, you have to, which one you have to give more force?
Train.
Yes, because its mass is greater than the car. Okay. Another way, if the car is in still condition and the train is in still condition, you want to accelerate them, you want to push them, you want to make them moving. So for car or for train, which will require more force? How you can say? If you want to uh, pull a, if you want to pull a cycle, you can easily pull. If you want to pull a train, can you pull? So which one will require more force?
Train.
Because its mass is higher than the car or cycle. Okay. Another way, if you if similar way, if you want to pull a glass of water, you can easily pull. If you want to pull a bucket of water, it will require more force. Can you pull one bucket of water of 10-liter bucket?
No.
But you can easily pull a glass of water. So lighter the object, less force is required to move. Okay. Heavier the object, more force is required to make it from still condition to moving condition. Okay. So the force, second law says the force acting on a body is equal to its rate of change of momentum, which is the product of its mass and its acceleration. Acceleration is nothing but degree of change of velocity. Change of velocity means something is when some still object is keep moving, its velocity keeps increasing. The rate of change of velocity is called the acceleration. Acceleration means uh, increasing its velocity. You know, when we start a car, first it is in still condition, slowly its speed is keeps going to increase. When the road is clear, we move it faster, more faster. Okay. If some object is coming in front of a car, we want to stop it, we have to keep brake, we have to push brake push jams the, acts a force onto the wheel and the car stops. Okay. If we do not apply brake, it will not stop. Okay. Brake is here, brake is a force. Understood? Second law. Give me example of the second law of Newton. By a cycle and a car, you give me the example of second law. If a cycle and a bicycle is in same speed, we have to, if we want to stop them, we have to give more force to the bike, we have to give more force to the car rather than the cycle. Okay, if the cycle and car is in still condition, and if you want to keep if you want to make it moving, you have to push, you have to give more force to car than cycle. Understood? Bigger the heavier the object, force required to move it or stop it is more. Okay,
Okay.
it's basic concept here. You understood?
Yes.
If you are pulling this clip, it is very lighter, its mass is very less, so you can easily move it. If you want to move this book, it requires more force. That's simple. Okay, understood? Third law is, to every action there is an equal and opposite reaction. So what do you understand by that? In every action there is an equal and opposite reaction. If you hit the wall will hit you in the same force, so you will feel the pain. Understood? Newton's third law says that every action there is an equal and opposite reaction. Why rocket moves forward? You know, rocket moves forward when the fuel from the rocket uh, comes out from it, it makes a thrust. It pushes hot exhaust gases with great force out of the back, and there is an equal force from the exhaust gases pushing the rocket forward. Understood, beta? Huh? The rocket releases gases, exhaust gases. Okay,
What is exhaust gases?
means gases come out from the rocket. Have you seen the rocket launching? You have seen that enormous amount of gases and vapors come out from the rocket. Okay, here you can see, here you can see when the enormous amount of gases exhaust from the rocket, it comes out from the rocket, the gases uh, forcefully come out from the rocket, the gases force backward to the rocket. Okay, rocket moves forward, it pushes hot exhaust gases with great force out of the back, and there is an equal force from the exhaust gases pushing the rocket forward. Understood? When it releases gases, the gases push it forward. Understood? If if you think that if you have you seen that if we put a ball into the floor, it bounce back, because when uh, the ball falls on the floor, okay, falls on the floor, it applies a force, gravitational force. The floor also applies a backward force to the ball, so ball bounce back. Okay, that is the third law of motion. So how many laws of motion is there?
He.
First one is,
Mm, unless it is disturbed by an force object will either stay still or travel at a constant speed in a straight line.
Okay. What is the second law?
The force acting on a body is equal to its rate of change of momentum, which is the product of its mass and acceleration.
What do you understood by this second law? Give me example.
If you the 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 thing it always be ছাড়ো তো আমি পারছি না